The circulation of deep seawater is being disrupted by melting Antarctic ice, which may further alter global weather patterns. Something unfathomably enormous is moving relentlessly, at a pace of only a few centimeters per second, down the smotheringly frigid depths of the oceans. It has been moving in this way for millions of years. Dense, black water rivers, which comprise around 40% of the deep ocean's total volume, labor non-stop all over the world. They are enormous conveyor belts that move nutrients, carbon, oxygen, and heat across the Earth, influencing the climate and weather locally, regionally, and globally. Still, something seems to be wrong, and these rivers seem to be waning. It should come as no surprise that climate change is to blame. The sting in the tail is that if this gigantic machinery slows down, it may accelerate climate change and lower fishery productivity, which is essential for the survival of a vast number of creatures, including people. The complicated connection between climate and ocean was seldom considered when the Intergovernmental Panel on Climate Change, IPCC, published its groundbreaking report in 1990, according to oceanographer and climate scientist Matthew England of the University of New South Wales in Sydney, Australia. He claims that the forecasts were quite basic at the time. They merely possessed a very basic ocean, with no dynamics connected to it, like, he says, the bathtub kind of thing. In addition to the fact that oceans are known to absorb heat and carbon dioxide, little is understood about how the ocean and climate interact. Since then, advances in ocean science have yielded a refined comprehension of the pivotal function that these worldwide ocean conveyor belts perform in influencing climate. As stated by coastal oceanographer Ruth Reef of Monash University in Melbourne, Australia, water moves, just like wind, in a three-dimensional space. We have currents that are going, say, from left to right, and we have currents that are going up and down. Wind drag is what causes the water to travel horizontally. Reef said, the ocean is dragged along with the wind when it blows across it. Changes in the water's density are what cause the vertical movement. The concentration of salt in the remaining water rises as salty salt water in the poles freezes into freshwater ice, making the water denser and causing it to sink. The conveyor belt engine has started at this particular stage. Trillions of tons of thicker, colder water descend to the polar region's lowest points before plunging through the abyss and heading toward the tropics. The water rises and warms there, and warmer currents travel around the Pacific, Indian, and Atlantic Oceans, releasing heat, oxygen, and nutrients, and absorbing carbon dioxide, before returning to the poles where the cycle repeats itself. One example of such a current is the Gulf Stream, which travels from west to east across the North Atlantic and sustains the relatively mild winters in the United Kingdom. Because of the creation of what is known as Antarctic bottom water, the Antarctic is the most powerful engine of this overturning circulation. But there's a problem with this engine. Physical oceanographer and climate scientist Catherine Gunn of the University of Southampton in the UK states, we show that a deep portion of the overturning circulation is slowing down, and the amount of oxygen reaching the deep ocean is declining. She has been evaluating changes in the development of Antarctic bottom water with her colleagues. A portion of the Antarctic shelf that borders the Australian Antarctic Basin and the Ross Sea was the focus of a newly published study that examined oxygen levels as a proxy for cold water flow. Cold water contains more dissolved oxygen than warm. According to their findings, between 1994 and 2017, there was a 28% decrease in the amount of this cold, salted, oxygen-rich water that descended to the ocean floor. Antarctic ice is melting more quickly due to global warming, which is most likely the reason for this deceleration. According to Gunn, the waters are fresher, less dense, and therefore less likely to sink because of meltwater from the Antarctic. The overturning circulation is halted by this. This scenario may seem a little familiar to you because it was popularized by Hollywood in 2004 with the highly anticipated film The Day After Tomorrow, which was based on the 1999 book The Coming Global Superstorm. The idea is that the North Atlantic Ocean circulation, called the Atlantic Meridional Overturning Circulation, or AMOC, unexpectedly stops, almost instantly causing the Northern Hemisphere to enter a new ice age. England isn't overly critical of the film, despite the fact that it is highly dramatized and fictional. However, he is not plagued by nightmares of a worldwide ice age. Sea levels are rising. The area of Antarctica that he and Gunn studied seems to be warming more quickly than other areas. And that presents a challenge because there is a significant amount of ice there that is barely holding onto the ground. According to England, this mechanism that surrounds Antarctica and forms cold, salty water acts as a kind of shield to protect the ice behind it. Because it protrudes from the continent's center, the ice shelf around West Antarctica is already more vulnerable to currents that ring Antarctica. England expresses worry that the process of overturning and slowing down could lead to the cessation of maintaining the Antarctic margins frigid and ice conditions. Warmer water encroaching on Antarctica's borders could cause the ice that is linked to the continent to break off and fall into the ocean. Sea levels could rise by more than 3 meters as a result of the catastrophic consequences. Likewise, there can be repercussions for the local and worldwide environment. One worry is that a slowdown in the AMOC in the northern hemisphere may coincide with or be a contributing factor to the slowdown of the Antarctic overturning circulation. Although there is considerable disagreement over whether this slowing is because of the current's inherent unpredictability, England claims there is evidence to imply that AMOC circulation has slowed by around 10 to 15%. Shenji Zhou, physical oceanographer at the British Antarctic Survey in Cambridge, UK, argues that might have a big effect on the UK and Western Europe. The UK will receive less heat if the AMOC slows down, which will result in even more miserable winter weather here, Zhou claims. That's just one instance. There are times when it's harder to tell how the slowdown will affect the local climate. For instance, in Australia, systems like El Niño and La Niña, which are predicted to strengthen with climate change and bring more severe droughts, heat waves, and flooding, are anticipated to have a greater impact on regional weather. In addition, as the day after tomorrow highlighted, there might be some cooling effects. As for the North Atlantic, England notes, we have a local cold blog there right now that people are saying, hey, look, there's the North Atlantic slowing down. However, he believes that the consequences of regional cold will probably be outweighed by global temperature rises. It also depends on how the overturning of the Atlantic and Antarctic interact. According to England, modeling indicates that a large rain band that typically lies just north of the equator could move roughly 5 degrees latitude southward if the AMOC slows down more than the Antarctic current. However, that belt of precipitation remains in place if the Antarctic changes counterbalance the AMOC current changes. An additional worry is that the collapse of this global warming conveyor belt would hasten global warming. The overturning circulation in the Antarctic is a major factor in the absorption of heat and carbon from the atmosphere, states Zhou. Basically, the conveyor belt stores heat and carbon in the ocean's depths for the hundreds of years it takes for the water to finish the cycle and rise to the top. The rate at which heat and carbon dioxide are absorbed at the surface and released into space at depths is decreasing due to the slowing current. Due to the fact that these deep currents bring nutrients that have settled at the ocean's bottom to the top, there may potentially be an effect on food security. Significant commercial fisheries are sustained in the areas where these upwellings occur because a plethora of marine life feeds on those nutrients. Reef states that different places of the Earth will experience upwelling at their doorstep due to changes in ocean circulation and density separation. Stopping global warming is the straightforward solution to a complex problem. England claims that we can't stop this without reducing our emissions. It is impossible to geo-engineer your way out of that situation. However, England is unsure that we will be able to undo these alterations in the short time remaining. He argues we could probably prevent that slowdown from being a full collapse with drastic action. But it's pretty tight. As Modurilio says, we imagine the end as a world-devastating event. But every time there's a terrible earthquake, a tsunami, an outbreak of disease that's apocalyptic, on a micro scale. You can suggest topics you want to see next in the comment section below. Please subscribe to Weather Collapse if you want to know more, and be updated on the latest news about natural calamities or disasters happening all over the world, and don't forget to like today's video. We'll see you in the next video. Thanks for watching.